Now, some of our very sophisticated models, twin engine models, carbon fiber fuselage planes, things like that, B-25, Tiger Cat, or a carbon fiber wing Testarossa. These are models that I've done a lot of bench trimming on before they ever get to be in the air. And a lot of it is a little more high-tech than most people really need or want to know, but I thought I'd include this in anyway. These are little tips, maybe a little higher end than you need to know, maybe not, maybe they're interesting, but this is some of the little approaches that I use to the model before I ever take that plane and put it in the air. Now again, this is made to relate to more sophisticated models, but let's look at some of the things. Maybe interesting, maybe not. Some of the things I've done over the years that have allowed me to get models bench trimmed and out at the field with very little risk to the model or to my ego. Now, and again, if you really like fancy drawings, you know, this is not the place to get them. Okay, we know that every model, and this is, again, this is going to be sophisticated more than basic. So we want to draw the line for the vertical CG. Now I'll explain exactly how you would do this on a high-end model. It takes a little more time and energy, but it's extremely accurate. Now I want to know which side of this model is it going to be that's the heavier of the two. Is it bottom heavy or is it top heavy? Plane's never been flown. I want all the paint dried. I want it buffed out with a propeller on it. I want it exactly as we're going to take it to the flying field. And I want to determine which way am I going to have to take some weight out or leave or put some weight on before I go any further on the development of this model. Now this would be something you would do to a full-size stunt ship, a full competition model. Now this is called plumb bobbing. You would take a beam in your house, in your garage, your shop, where there is no wind blowing. Take a hook and a string. The finer of a string, the better. Preferably, if you can find it, the chalk line type of string. That's a color. Yellow is what my choice is. And a little weight. The weight can be anything. All the weight does is establish the plumb bob. Now, and that plumb bob establishes a perfect vertical line. Now, what you would want to do is directly in a line of sight of this, put another hook, maybe make a little S hook, put the lead outs of the ship in there, and you'd want to hang the model from the lead outs. Now at some point in time what you want to do is first, here's what happens when you do this. It takes about 2 or 3 minutes for everything to stop pendulating. It'll eventually, if there's no breeze blowing, no other motions, this will settle down. And what will happen, these two will be sitting parallel. Now you can walk to where your eye picks up both of them at the same time. And as you do, you can sight down the wingtip and it'll usually be off a tiny amount. Now if the wheels are heavy, picture what's going to happen. This is going to go out like that. And you can sight it, and it's very obvious when you do this if you're close or not close. The way we did on the basic, that shows you the basic way to do it. This is the advanced way, the very sophisticated way. Now I had to do this with my twin engine planes, my bombers, the Tiger Cat. The problem with doing this is it's very accurate, and a lot of times it's more accurate than you need it to be, but it's always nice to be more accurate than less. So if you're going to try doing very sophisticated trim, this is a good place to start. Establish a plumb bob, and establish, when you look at the two lines together, that you can sight down it, and just to exaggerate it, let's exaggerate that the wing is going to look like this and the plumb bob is going to come down like this. You can see right away, and you sight the difference by looking at the wingtip And you can spot those too. It takes a little bit of doing, but almost every really accomplished modeler has his own trick little way. This is my way. I learned this from Big Jim Greenaway, who Bob Barron did it this way, among other people. They very carefully plumb bob the model, and it's a very accurate way to do it. Again, this is the next level of modeling sophistication. Getting the vertical CG exact before you ever fly the plane. Now, in the case of some of the models that I've had, about the best trick I've ever seen for making a bench trim go easy is, I've seen several people do this, is take the spinner, the prop, and let's make a pretend up they had a Cardinal or Strega, and they built a new one. Take the spinner, the engine, the glow plug, the tank, even more critical, the tank shim, so that the tank doesn't even have to be shimmed. The prop that's been used for hundreds and hundreds of flights and has exactly the right pitch in it. All of this stuff, I would call this a powertrain. Now, that's real easy to do. Now, what I did in the B-25, when I was done with the B-25 and I started the A-26 project, I took the motors out of the B-25, the motors, the tanks, and everything, for the first couple of flights, so that there was no chance at all that I was going to have some big surprise that the tanks were out of shim. Having a tank, a proven tank that doesn't have, hopefully, a lot of stuff in the filter. Having a motor that's got couple of years of runs on it, it's well worn in, a glow plug I know, a prop that's balanced and has the correct pitch. Having that powertrain developed, and then having, here's the old ship, you know, and here's the new one, and just take that right out, put it in the new plane. Boy, does that make it a lot easier. Now, it also gives you another advantage. And you don't think of this advantage until all of a sudden one of these days it like a light bulb goes off. Is here. Now you have the old ship, in my case it's the Spitfire. And I can put a brand new motor in here, get a tank shimmed, get a prop balanced, get my whole powertrain worked out in an older plane. And then when I build the new version of that plane, plug it right in one shot. And wow, I'm now months ahead of having to switch props, having to switch this, having to shim the tank, having to change the glow plug. By taking a powertrain swap, I can eliminate a lot of the variables on the first couple of flights. And I save all the aggravation of when I'm going to develop a new motor or get that first couple of gallons of fuel through it, why not have it in an old plane? Let it run in an older plane and bring it up to its prime, and then plug it into a brand new plane. A well-worn, well-proven powertrain, the whole powertrain, swap it in one shot. And that's one of the sophisticated ways. I'm sure other people do the same thing. This is not some secret thing. This is something that's worth doing on a high-end model. Now, typically, to finish on a brand new plane, assuming it's Brodak dope, that dope is, at best, it should sit about a month. Now, at the end of a month, it's pretty well gassed off, cured out, assuming it's buffed or not buffed. Again, we're talking about high-end models. But at the end of that month, it's time to wax it. Now, I would not wax it until it's a month old. That's for sure, because you're just sealing in any of the products that still want to outgas. But what I would want to do is if, for instance, the model were 2 weeks old or 3 weeks old and it's ready to fly, you have that beautiful flying day, I'd want to wax it before I ran the engine. Now, how many people have had a problem of they've been very anxious to get to the flying field and just put a coat of Pledge on or a coat of one of these spray waxes? What you really want to do is wax it with Carnauba. Go to a store that sells any kind of car wax and you'll notice the products that are in wax. Pure Carnauba without cleaner. This is solid Carnauba, very expensive. But what this does, the more Carnauba in the wax, the better it's going to protect from fuel damage to new paint. And typically a lot of people that live in warm weather climates where you can fly the model the day it's finished, might skip that step, or they'd, even worse, they'd wax it before the dope has gassed off and chemically hardened. Well, in the best of all worlds, a month is my baseline. When it's a month old, I like to wax it, and then after it's waxed, then run the motor. And that time window has worked well for me. Now, if you're using fuel-proof epoxies, some of the automotive finishes, the two parts, they tend to be more fuel-proof, but they are heavier. So if you're a light builder and you can afford that, well, that's nice. But in the case of Brodac dope, you know, the thing that you buy with Brodac dope is extreme strength, and it's almost always going to come out lighter than any other finish you can come up with. Now, one of the questions a lot of people have is they build a high-end plane or an advanced level plane, and it incorporates, the designer incorporates in the Raby rudder linkage. Now, I would suggest if you're building this type of a plane, a semi-scale plane, and you want the dimensions and movements, the easiest way I know is just to contact Al Raby. He seems to be very helpful and very willing to share what he's learned over the years. Now, I've used Raby rudder linkages on pretty much every plane I've built in the last 15 years, except the twins, which for their own independent reason didn't really require it. And I've come up with a little formula for the things that work for me. Now, on the Spitfires, all of the Spitfires share a common linkage, a common formula for laying out the linkage. The ships like Miss Ashley and like the Testarossa pretty much share the mechanical geometry that we've come to use over the years. So what happened is when we had the Testarossa ready to set the linkage up, we pretty much know what the formula is going to be. Now, a typical linkage, and again, Al Raby is the one that I think is credited with this, let's call it an invention, but other people certainly have used it and certainly fine-tuned it to meet their needs. Now, on a semi-scale plane, if you have a ship, and I'm going to do this two ways. You have a traditional stunt ship and it has about 10 inches of rudder area. A Cardinal has about 10. A Strega has about 10. If that rudder area is about 10 square inches, nice pen. Now, with that in mind, if you have a ship and it's got 10 square inches of rudder, this is the formula, or this is the geometry that I would suggest using when you bench trim or build a plane. If this, let's pretend it's a semi-scale plane and it's got a big giant rudder. Well, if it has a lot more than 10 inches, well, I'd want to interpolate accordingly. But the planes that trimmed out real quickly, using about 10 square inches of rudder, use this formula. And this is on the Spitfire and Seafire plans, but we'll make this is the little drawing that I think has worked well for me. Where I want to locate the pivot point, this is my 1/8 inch horn in the edge of the elevator. And I want to measure back roughly 1/4 to 3/8 of an inch. 3/8 would be my first choice. Now, it's this measuring back from the pivot point that builds one of the exponentials into the system. 3/8 of an inch is good to start. And then you want to locate the pivot point. In this case, I use a piece of 1/8 inch tubing right up on the 1/8 inch horn. So it's 3/8 back and as close to the control horn as possible. That's the pivot point. Now on the rudder, and again, this would be the top view. That would set your pivot point right in there in the elevators. That adjustable linkage is going to come back. Now, again, we're assuming 10 square inches. I want the pivot point to be, if the hinge line is here, I want the pivot point to be about 1/8 of an inch behind it. And I want to go out with several adjustments, roughly an inch, so that I have a hole at 1 inch, a hole at 7/8, a hole at maybe 3/4, but I want to have several choices of ratio, and that would be attached to the edge of the rudder. Now, once you build this, and you could build this right off any of the plans that show this. A lot of Al Raby's planes show the exact linkage he used. This is the formula that I used. Now, when you set this and adjust it, usually there's a little adjustment. You can use ball links, clevises, any number of things. But getting the movement as a starting point, this is one of the things I like to do on a bench, is to bench trim this. So this would be the rear section of the fuselage. This would then be the rudder. And I would somehow accurately figure where the center line would be. Now, there are a lot of different ways to do this. When you have the horn, the adjustable horn, you can set this so here's what happens, and a lot of people don't understand this. They think that this is moving up, down, just like an elevator is. It's not. It's on an offset linkage, so it should never move in the direction toward the middle of the circle. I would want it to be, if anything, the furthest it ever moved from neutral is maybe 2 or 3 degrees of positive offset. And when it's adjusted correctly, and again, you have to play with your linkages, to get 10 to 12 degrees of offset. If you're using a bigger prop, more rudder. Smaller prop, less. But it'll always be to your advantage. It'll never be a negative thing. And if you can bench trim in, this is one of the things I don't really like to do at the field. I like to get this set as close as possible before I fly the plane. I want to have my linkage adjusted, and usually, again, there's a little clevis or a ball link that allows you to adjust it. But you can, by shortening a linkage, you can get more and more control, more and more offset. By moving the pivot point closer to the fulcrum, you can get more travel quicker, and by moving it further away, you can slow down the travel. Now, where this is really helpful is having all these adjustments. If you don't like it, you can just simply take the linkage off and run a wire to the side of the fuselage and make it an adjustable rudder. Don't make it anything. Just eliminate it altogether if you don't like it. Now, whenever I set up a new ship with a tuned pipe, there's a couple of things I like to keep in mind, especially if the engine is new or relatively new. Number one, after whatever break-in the manufacturer recommends, or whatever break-in you have, or if it's a used motor, even at that, what's a good idea is the first flight, either put a prop on that you know has the right speed and the right load, and again, there's a prop DVD video that really goes into detail. I'm not going to get into too much detail, but these are the things to avoid when you're bench trimming. Don't put on a prop that's too big. Don't want to have, for instance, if you have a 60, you don't want to have a 14-inch prop on it. You want to, or if you have a 40, you don't want to have a 12-inch prop. You want to have a prop that's appropriate for the engine. You'd like to have the piston and liner worn in, broken in to the point where it's a friendly engine. Here's what I always do, and this is really a good trick too. I always take on a used plane, a plane that I fly, an ARF even, it doesn't matter. and it doesn't matter what engine it is. Take a glow plug, run it, take a brand new glow plug out of the box, the brand of your choice, run 5 flights on it, take it out, put it in a little bag, and the bag should be marked tested parts. I'd say 5 flights would do it. Then that plug would wind up in that bag. Now, I would take 5 flights more on another plug, put that one in the bag, until I have maybe 3 or 4 spares. Now, these are not new plugs. When you're flying a plane for the first time, you'd like to have a reliable plug. And I've seen many, especially Fox 35s. This is the greatest thing. Fox 35, it's running along, the guy does a loop, he goes inverted, motor shuts off. Now you have to land it inverted. One of the reasons is because he didn't have a tested plug, or a plug that was a known quantity. So I always have this little envelope of tested parts. Now, in tested parts would also be another possibility, the fuel filter that you're using. Whatever brand that is, whether it's Crap Trap or Rich Oliver's or Sullivan or whatever. Get 5 flights on it, back flush it and clean it. Have a spare filter or 2. So now when you set up a new plane, you don't have a new glow plug and a new filter. You have proven things. Now, just as an example, this is what we have for the Testarossa. And when I had the twin engine ships, I had 2 of everything. Proven filter, a filter that's not brand new, it's been in a plane, I know it's not leaking or loose or there's something, the screen is pinched or anything, and a glow plug. And hopefully, if you have a choice, if you look down a bunch of glow plugs, here's what you really would like to look for on a plug, is that the coil is right in the middle, if you have a choice. Now, if you don't, obviously you don't. But a lot of times you buy even brand new plugs and the coil will be way off to one side. These are the ones that usually give you a problem. These are the good ones. These over here, especially on a first flight, especially when you're nervous about, oh my God, I got a million things, got my whole winter project here, this is my pipe with my $500 engine, and here I am, and boop, the plug shuts off inverted. That's a tip worth its weight in gold. I think you'll eventually become a believer in tested parts. This is something, I don't know any top-level flyers or people that I really know have been around for a long time that take a new glow plug or a new anything filter and put it in a new plane. They always want to have tested parts. A great tip, I think. Now, when I'm setting up a pipe engine, another thing to keep in mind, and each engine would be individually tuned, but wherever the baffle is, and let's just pretend for a minute that you've run this motor and you know that the dimension that your pipe length has worked out to be is 17 3/4, which is a typical for many 60s. Now, when you're going to fly a plane for the first time, or a motor that's new, if it's a new motor, a new prop setup, any kind of combination of new, what I always like to do is move the pipe back just a little bit, a 1/2 inch, 3/4 of an inch. The reason for that is it almost minimizes the chance that you're going to get some schmutz from the tank in the filter. You're going to get a lean run. And as soon as the guy releases the plane, or as soon as it goes inverted, it's going to go dead lean. When the pipe length is long and you get a lean run, not much bad happens. When the pipe length is short and you get a lean run, you can easily either hurt the motor, damage the motor, or just stay out at the middle of the circle for 20 minutes. And I'm sure anybody that's done pipe testing, and there's videos that explain more of this in detail. But the one scenario you want to have on a new plane, anytime you have a new plane, you want everything to be safe. You want to be, I call it safe mode. Well, the motor safe mode is relatively long pipe, longer than standard, proven glow plug, proven filter, and a prop that's either right or a little bit smaller, not a prop that's going to overwhelm the engine and cause it to overheat. Now, how would I go about setting up, especially an elaborate stunt ship, a pipe ship, a twin engine ship, I'd set it up for the first flight in safe mode. Now what safe mode means, it's not as complicated as it sounds. The model is being held out on the end of the lines by centrifugal force. The biggest component of that centrifugal force, or what we commonly feel at the handle of line tension, is the weight of the model. The sheer weight of the model, let's say it's 40 ounces, it's 50 ounces. The more the model weighs, the more that force is going to act to make line tension. Now, the worst thing that can happen on the first flight of a plane, the absolute worst thing, is that your helper or stooge releases the model and it rises off the ground and comes in the middle of the circle and crashes, hits somebody, damages itself, or just, in some cases, scares you to death. So for a first flight, when you're going to be nervous anyway, there's a couple of things you can do to ensure that that's not going to happen. The biggest one is put more than the tip weight you anticipate needing. If we think we're going to wind up needing an ounce and a half, or if the designer calls for an ounce and a half, you know what? Safe mode. Put 2 ounces. Put a ½ ounce extra tip weight in the plane. Now, that tip weight, what it does, it's going to generate a force. The wing is, this is going to want to pull back, and it's going to, in essence, crab the plane, turn the plane away from you. So even if the lines were to snag on the grass, or if you have a helper that's not accurate about the launch, or it hits a bump, or lines catching the grass, and any number of things, this is the lifesaver. This is the lifeboat on the Titanic. The other thing I would for sure, I'd always want to have safe mode, and I always recommend taping the hinge lines. Absolutely, and we've done that before, and that's on many other videos. Also, I would want to have, if we have 0 motor offset and it's measured accurately, and those dimensions are accurate, maybe for the first flight you want to loosen the 4 bolts and just cant the motor out even a little bit. Give yourself a little bit of out thrust. Again, for a first flight, or for, in any case, a new model is always an unknown thing, and there's always a myriad of things that can happen that can take the fun right out of a flying day. Being in safe mode. Safe mode would be if you have an adjustable rudder or an Al Raby type rudder, give it a little more offset than necessary. The combination of all these things is going to result in way more line tension than you'll need. But after the first flight, you can take a ¼ ounce out. After 10 flights, take a little more out, and then refer to the trim video for exactly how to get the wing evened up. Well, the motor offset, you might want to try it at 1 degree, at a ½ degree, and at no degrees. But for that first flight, or until you familiarize yourself with the model, also extra rudder, and at no point in time, especially if you have an adjustable Raby type rudder, at no point in time does that rudder point the plane in at you. Those are kind of basic safe mode things. Motor set up in safe mode, plane in safe mode, probably means that first flight will be a rewarding experience. Now, many of the planes that we all enjoy building and flying were designed years and years ago, before we had as many choices in motors. Let me just explain one of the things that can happen to somebody when you take a design like a plane from the 80s or the 90s that was designed before we were all using tune pipes, or most were using tune pipes, and now you want to convert this model to be a pipe ship. So I'm just using the Cardinal as an example, but this would apply to a Strega and any plane that was designed not to have a pipe, but you want to put a pipe in it. Well, here's what's going to happen. It happens. Most people immediately realize this. Here's our vertical center of gravity. This is kind of advanced stuff, but this will be good knowledge at some point. Almost everybody does this at some point in time. Well, what you see right away is you have this amount of the model above the center of gravity. And probably when the designer designed the model, he built a few of them and figured out he raised or lowered the wing until that got to be exactly how he wanted it. But now what happens is, People come along, a Strega is a good example of a plane that a lot of people have converted over to a pipe. So what they do is they add maybe 1/4 of an inch or so to the length of the fuselage, the side view of the fuselage. Now you can see what almost guaranteed is going to happen. This is wood, glue, material. It's all below the center of gravity. Now the typical motor that everybody would be using in some of these planes, the more modern motors are a little bit larger, especially the 76s. Where they build up the weight is right here at the head. So now you've got a plane maybe that was originally designed for a 60, and a Strega is a good example of this. And now you've added, and we'll put this, typically adding about a 45 or 50 gram pipe, a header. Notice what's happened. Virtually all of the weight that you've added is below the center of gravity. But now what can you do about it? Well, there's an obvious thing you can do to make up for it. Done this a million times too. Take what should be the aluminum, or was the aluminum landing gear if it has it. Aluminum gear, typically 2.5 ounces. Replace it with a carbon gear, typically 1 ounce. Now, it does a couple of things. It gets 1.5 ounces off the plane, and you've already added some of that weight, so it gets it back to where the weight is in pretty much the same. But it also gets the vertical CG back to where it's realistic. You also could use, at this point in time, you know you've added weight, so the choice would be make the lightest set of wheel pants and absolutely the lightest wheels possible, because you know you've added, anytime you add to one side of the seat, you've added something, you've got to take something away, assuming you want that vertical CG to be just right. Everything you give, if you can balance it and you can take it away, the same as when you're replacing parts to get the normal CG right and you're replacing from the front back, this is one way that I've done over and over and over again of getting the vertical CG right. Here's an example of 2 of the planes that in the past had vertical CG issues, were converted back and forth from pipes to mufflers to 4-strokes, and in the course of doing that, to get the vertical CG right, very, very light, thin wheel pants and carbon fiber gear. Some of the other things I want to check before I fly a model. I want to look from the front. This would be my front view. And I want to ensure that the stab and elevators are straight. I don't want the stab and elevators to be crooked. And what can happen is, from finishing the plane, doping it, having it sit out in the sun, whatever, this can warp on you. And if that's warping one way or the other, it's going to be a trim problem to deal with. So I want to see that I have 2 parallel lines, one going right through the wing, the stab, and that these 2 dimensions are equal. That's one of the key things of bench trimming a plane, trying to get it stacked, that as many things are straight and many things are aligned as possible. Now I'm looking at this point in time from the back, and I'm sighting down the flaps. I want to ensure that when I start, may need a flap tweak, may need a trim tab, but I want to start with everything in neutral. I don't want to start with one flap radically up, radically down. Remember, when the plane is in safe mode, what happens in safe mode, it masks over. Here's what would happen if you had this flap up, incrementally up. The extra tip weight is going to keep that, is going to offset that to a certain amount. So it's going to mask over a warp or a misaligned flap. But as you start taking the tip weight out, you're going to start to see if everything is neutral and level. So I like to hang the model by the lead outs and stand back 8, 10, 15 feet and just look right down that flap line. Now another thing I want to check while I'm doing my bench trimming, I want to be absolutely certain of one thing. That when the motor thrust line, and that's already built into the model, or you've built it in, so it's a little late to be trying to line that up. But I want to make sure that that line and the line that would go right through the center of the wing, these all come out neutral at the same time. Now, it's very easy, especially in a world of adjustable controls. A lot of people will get the wing in straight, but the flaps, and while the flaps are in neutral, the elevators are slightly up. Or the elevators are level, flaps are slightly down. What we're really looking for is to get, during the building phase, the thrust line of the motor, center line in the wing, and that includes the flaps, and the center line of the stab and elevator. These three lines to all line up and all be parallel at the same time. Now another thing that I do, and it's a little extra work, it's easy to make yourself a gauge. All you need to do is get a piece of cardboard or paper, stick it in a flap hinge line, like so. Put a little piece of Scotch tape wherever. I think I remember doing this on a Tiger Cat too. Do the same thing up here. Piece of paper, you can actually do it with tape even, but you need to hold it steady. And on that, on both of them, scribe out what you think is the center line. Now, when you pull full up, let's see, this will go down, this will go up. We can measure this amount. Now, I can work the controls in the opposite direction. What I'm getting at is I want to see if I have pretty much the same amount of up as down in the travel, but most of all, that when everything comes back to neutral, it all comes back to neutral at the same time. And you don't need to fly the model to do this. Getting this all lined up ahead of time, instead of going out to the field with something that's rickety and then trying to figure it out at the field, you can make these little pieces of paper, a little piece of tape will even do it. You could also, if you wanted to, you could make like a protractor. I think Tom Morris did this at one time, to show that you had the same amount of up and down in degrees. I think that gets a little more sophisticated than necessary, but I sure want to know if, for instance, if I look at this, if these boxes look like this, and I have where I think the center is, and I have this much up in a flap and this much down, wow. If I have that totally asymmetrical, the plane probably isn't going to fly level, it's not going to turn properly, it's going to have a million things that it does wrong, and it's going to make you crazy. It's just not going to be a fun day at the field that first day. The whole objective of what we do is to make the first day safe, enjoyable, fun, and that you got a day in the shop. You can use a rainy day, you can use a windy day, a cloudy day, a day you don't care, a night, an evening. And then when you get to the field and you have that beautiful day for a first flight, that you've not wasted that whole day trying to get the controls level, a tank shimmed, the right length lines, and get everything in safe mode and the plane's tail heavy. You can try to eliminate as many of these things as possible. Now, in the past few years, I've made 3 twin-engine planes. These are relatively sophisticated models, but I learned a lot of little tricks, and I thought I'd put right on the end of this DVD some of the tricks that seem to work well on twin-engine planes. And plenty of other people seem to be interested in twin-engine planes. We've had an awful lot of input and feedback, and I'm trying to condense this down into where some of these do's and don'ts with twins will make sense. And some of the development of this twins, I look back at my life and it was some of the most exciting years of my life working with these twin-engine planes. Jules Berenger flew his Comet at the World Championships, and we've really got a lot of good video of him flying it. We learned a lot, even in discussing some of the technology with him that he used to make this model. And of course, then at the next level up is Paul Walker's B-17, multiple engine model, extremely scale, really unique model in a lot of ways. Now, in making these models, there were a certain set of rules seem to apply to all of them. They all shared common threads. Now, some of the things I learned, and they're really not what you'd expect them to be. One of the things I found out right away, that if you're going to have a twin engine plane, it's really to your advantage to have the two engines at 0 offset. Now, I tried this many different ways. I tried offsetting just the outer engine, then both of the engines, then trying combinations of making them both in thrust just a little bit. And people that I really thought had different ideas than I did, I tried things that they said, but in the end, all three of the twins wound up, if I were to draw a straight line through the props, and that was a key thing to getting them to fly as good as they flew. And if we have any time at the end of this video, I'm going to look for one of those flights. You can just get an idea of how well they were trimmed. They really were trimmed out pretty well by the time we got to fly them in competition. But here's the other point. At some point in time, the rules changed during the time I was building this. In the very beginning, we had to have 235s. Later on, we were allowed to have, actually could use 245s. But when I put the bigger engines in, performance on all three of the twins went up dramatically. So what I'm suggesting is, if you're building a twin engine or a large plane, a plane that's going to weigh 75 to 80 ounces, use the biggest motors possible. Set them at 0. Again, tape the hinge lines. I never flew any of those planes without the hinge lines taped. That was a key thing, key critical thing. Also, the way these models flew relative to each other, all three of them shared common traits. They both weighed around 80 ounces, give or take an ounce here or there. But they all had really sharp, good corners. They really had good power delivery. I was very impressed, and many people have told me, people that have an aerodynamic background, that 240s make a lot more power than 180. The swept prop area is a lot more for two. I think we were running 11.5-inch props. We were running Doran's 11.5-inch props to 3 blades. That swept area is a lot more than one big engine would be able to use. So the helicopter effect seems to work well on twins too. But it was very critical to get those motors in place like that. Also, a couple other little incremental things that worked well. Now, I had, at some point in time in the course of doing this, and I had run 135 and 140. Well, it always was the best with the bigger motor or the more powerful motor, or a motor that just ran better, if they're both the same, on the inside. The inner motor is doing a lot more work than the outer motor in terms of getting the plane to fly. I'm not sure aerodynamically why, but whenever I'd swap them and put the strong motor on the outside, never quite felt or flew the same. Inner motor. Now, another thing I did, when you want a twin to shut off, let's just say the outer motor, here's the inner motor. It's a good idea to make the inner motor have a slightly bigger fuel tank. You'd always prefer, and I mean it goes without saying, you'd always want the outside engine to quit first. If they don't quit exactly the same, let the outer engine quit first. That immediately gives you the choice of the model not wanting a cant in. It doesn't yaw or pitch anywhere near as bad. So if you have a choice, let's say if you made the inner tank a 1/4 ounce bigger. Now, another thing I always found, let's look right at the front of the engine, and you can see this on startup. I would always use an electric starter. Always. Here's the reason. Many people watch them, especially scale flyers that don't get to fly that often. They get this motor started, reach over, get the glow plug off. Now you go over to this motor, flip, this one's running. and this one shuts off, and you reach over and you wind up cutting your arm. When you're dealing with this scenario, I would always start the inner motor first. You could see my starting routine many times on the video. Get the battery off. Then get this motor set. If you're not happy with the way they're running, adjusting the needles or whatever you're going to do, but if one motor in the middle of everything shuts off, just point the nose down and let them both shut off and figure out what's wrong. Going to restart that inner motor while this one is running is really a high-risk thing. And several people that I know personally, especially on scale planes, have reached over and totally forgotten. That prop catches them right there. So my suggestion is, if you're doing twins, always use an electric starter. Now, I've been really lucky to have a life of modeling that has been both interesting, rewarding, and I've been able to earn a living doing it. So for me, it's kind of special. And some of the things that really make it special are the people and the friendships that you make worldwide. And I hope from this video you're going to get some good basic ideas, some information you can put to use bench trimming in the next model or the one that you've got in your Air Force right now. And I remember in my house I have what I call a Spitfire bedroom. I have Al Raby's Mustang up here. Two of my Spitfires, two of the three, they're basically in retirement. And a lot of times I'll just come up here and think about the time I flew these for the first time. And boy, that first flight, it can be an adventure if even one little thing goes wrong. And I've said before, you know, suggest always putting everything in safe mode, and of course always bench trimming everything. And never risk the model on old lines or old handle cables or any of the things that can really just come back and bite you. And I hope you've enjoyed the DVD. Please pass it around. Please share it with all your friends. And keep in mind we have 850 DVDs and videos and our subscriber videos. Anytime you want, you can look at our website, wendyertnowski.com.